Amazing people. What we're looking at now is how to find the mode of a continuous probability distribution. Now, what you might know is mode is the most occurring score normally when you're working with statistics. And in the case here of continuous random variables and continuous probability distribution, what the mode is it's the point with the highest probability. So in many cases, this is the maximum point of a probability distribution function. So when we're doing this, we're going to do this in a couple of ways. First of all, let's look at what this looks like on a graph. Now, these two graphs here, you can see that what we're seeking to find is we're seeking to look at the high points of these, because that's where we're going to find the mode in each of these. Now, the first one is just like a hill, and so it goes up and over, and you can see that the mode is going to be this point here. And so what we would say from this graph here is the mode is equal to 4, and you can quickly pick that out from that graph. In the second one here, there's a high point, but then it comes down a bit, and then it goes to an even higher point. We need to make sure we're picking the highest point here, and that's going to be this point here. And it's just a matter of working your way down, finding out where that matches up on the x-axis. And so in this case here, what we're going to have is we're going to have a mode which is halfway between the 4 and the 5 roughly. So that would be a mode of 4.5. Now, when we don't have a graph and we've got equations which we've got to deal with, the way we go about finding out the mode is we need to use some calculus in order to work it out. So in particular, what we're doing is we're seeking to find the maximum turning point. So this is going to be a stationary point, and just check that it's got its concavity. So it's concave down at that point, which is going to be a maximum point. Now, here's our example here, and we're asked to find the mode of f of x equals it's divided up as a fraction. So on top we've got 3x open bracket 6 minus x close bracket, and that is all over 92. Now, first thing I want to do here, because of the way it's set out, I really want to expand these brackets and simplify it just to break it down. So when we do that, it's just going to make it a bit easier for us to work out the other parts of it. We're going to have f of x. The first part of this is going to be 9 over 46x, and that's also going to be minus 3 over 92x squared. Okay, so this is what I really want to use here. Now, from this, first thing I want to do is I want to find f dash of x, and the reason I'm doing that is I want to solve for f dash of x equal to 0, and I want to find the stationary point here, or stationary points. Okay, so what this is going to do is this is going to help me understand where that highest point is here. So as we work this out now, we're going to have f dash of x. That's going to be equal to 9 over 46 minus, when we integrate this one, we're going to bring the 2 down in front. That's going to cancel with the 92 to give me 3 over 46 x when we take 1 away from the power. So now with this, I need to be able to solve it. And remember, I want it to be equal to 0 to find those turning points. So I'm going to have 0 is equal to 9 over 46 minus 3 over 46x. Rearranging this, I'm going to have 3 over 46x equals 9 over 46. And again, rearranging this, I'm going to divide by the 3 over 46 on both sides of the equation. And when I do that, I'm going to then be left with 9 over 46. And when we're dividing by that fraction of 3 over 46, it's going to flip. It's going to give me 46 over 3. Got some cancelling happening here. That's going to go and become a 1. 1, that's a 1, and this becomes a 3. So what I end up with is x is equal to 3. So I've got my first element of this. So now what I want to do is I want to take this point and I want to test the concavity here. So in order to do that, what I need f dash of x. So I need to find f dash of x to test concavity of that turning point. So when I do this, I get f double dash of x. In this case here, that's going to be equal to just negative 3 on 46. And so if I did that substitution, then I would do f double dash of 3 into this. Well, that's still going to give me negative 3 on 46. So what this tells me then is that at x equals 3, f double dash of x is less than 0 because it's negative. So this is concave down. And in addition to this, if it's concave down, that means it's a maximum point. So what this is telling me then is this is the maximum point which I have for this function. And so hence, the mode in this case is equal to x equals 3. That's where we find the mode.